Set E, Chapter 10, page 175. For the men in Haynes 5, 18 to 24, the ones who were 63 inches tall averaged 138. True or false? The ones who weighed 138 pounds must have averaged 63 inches in height. False, because if you look at the averages of 63 inches, you're looking at a vertical column. And that vertical column has a center, which would be the average in the middle. And then if you do the average heights of the weights, you're looking at a horizontal column. And that horizontal column is going to have an average that's in a different place. So the, oh, I see what you're saying. So height predicts weight pretty well. Does weight predict height very well? So this line would be called the SD line, right? And then if we take the columns and we cut the columns in half, then I create the regression line. But if I take the widths and I cut the widths in half, then I get this other line, which is sort of like the reverse regression line. So the first regression line is the X on Y regression. So the height given, the weight given height. The other regression line is the weight regression line. It would be height given weight. So they're not the same thing, and they don't predict the same averages. And that's not terribly important. As far as I can think, we're not going to use those regression lines like ever. 2. In Pearson's study, the sons of 72-inch fathers only averaged 71 inches in height. True or false? If you take the 71-inch sons, their fathers will age about 72 inches in height. False. It's the exact same question that we had before. Okay. And example 2, the regression method predicted that a student at the 90th percentile on the SAT would only be in the 69th percentile on first-year GPA. True or false? And explain. A student at the 69th percentile on first-year GPA should be at the 90th percentile on SAT. That would be false for exactly the same reason. Okay? The X's that predict Y's do not translate into Y's that predict X's. It just doesn't work that way. All right, that was easy.